What are conic sections? You may have already seen conic sections before and not even known it. Think about a circle or a parabola. Those curves are types of conic sections. Now we may know what they look like, but how do we find them? Well, to see how conic sections are formed, take a look at this double cone. What if we took a plane and just sliced through this cone with it? Well, let's do that. Let's say that we take this plane right here and intersect it with this double cone. Well, where we have that intersection is a conic section, that curve we get from the intersection. So, conic sections are curves that are formed by the intersection of a plane and a double cone. Now, we can actually get different types of curves depending on how we intersect that plane and double cone. So let's take a look at the different types of curves. Say we take that plane that we just took and slice it directly on with the double cone. Well, the curve that we get, if we graph it, looks like this. So we get a circle. Cool. So taking a plane and slicing it directly on that double cone gives us a circle. Now what if we do almost the same thing, except we just angle the plane a little bit more, so it comes in like this? Well, this shape creates more of an oval curve, and we get a graph that looks like this. This is called an ellipse. So, intersecting or slicing that plane with the double cone at a slight angle gives us an ellipse. Now, what if we do something like this, intersecting that plane and cone to get one of these U-shaped curves? Well, there we could get a graph that looks like this, or this flipped over, or like this, or this flipped over. All of these are called parabolas. So here, if we see a graph like this, that's a parabola. And you've probably seen those before. Parabolas are the graphs of quadratic equations. Okay, what about this type? If we take our double cone and our plane and slice them like that, we get a U shape up here and another U-shaped curve down here. Well, there we can get a graph that looks like this or like this. A graph or curve that looks like this is a hyperbola. So here, this type of slicing will give us a curve that's called a hyperbola. Cool. Now, if we take a look at these graphs, the only one of these that is a function is this version of the parabola right here, or a downward-facing U-shape. It's the only one that passes the vertical line test. Now, the equations for all of these curves can actually follow one general form. So let's take a look at the general equation for a conic section. If an equation can be written in this form, then we know we have a conic section. Now, all of these different curves actually have their own specific general form, but they can also follow this general form for a conic section. With this equation, A, B, C, D, E, and F are all constants. And A, B, and C cannot all be 0. One or two of them can be 0, but not all three. Otherwise, we will not have a conic section. To get a little more familiar with this equation, let's go ahead and take a look at a couple examples of equations that are conic sections. So let's take a look at this equation right here. Comparing it to our general form equation, we can see it does follow the form for a conic section. But remember, those constants A, B, and C cannot all be 0. Well, if we take a look at this equation, we can see that the constant B is 0. But A is not 0 and C is not 0. So here we have a conic section. And actually, a lot of times it can be helpful to be able to take these equations and rewrite them in a different form. Each of these curves has its own general form. So if we can rewrite the equation in a form that follows one of our curves, it can actually make it easier for us to figure out what that graph looks like. We can take this equation here and rewrite it in this form. An equation in this form is a hyperbola. That's what this equation follows. So if we were to graph it, we would get a hyperbola. Now, what about this equation? Well, we can see it does follow that general form for a conic section. And if we look, A, B, and C are not all 0. Here we have a -3 in front of y squared, so C is not 0. A and B are both 0 in this equation, but C is not. So we do indeed have a conic section. And if we take this equation, we can actually rewrite it so it follows the general form for a parabola. Here, this equation follows the general form for a parabola. So if we were to graph the equation, we would get a parabola. So now we know more about conic sections. Conic sections are the curves we get when we intersect a plane and a double cone. Depending on how that intersection occurs, we get different curves.